Hey guys, this is Carrie, and this is the answer key video for homework number 3. So, we got a bunch of these sort of polynomial division type problems. They all look pretty different, but we're going to see that they involve a lot of the same skills to solve them. So, for problem number 1, we've got one polynomial being equal to the result of distributing these two. So, let's start to distribute these and see if we can determine B and C. X times 2x squared is 2x cubed. Great news, because we wanted 2x cubed. Now, we're doing the weird distribution where we switch back and forth to make sure that the like terms match. Negative 6x squared. Oh no, that's a problem. We wanted negative 2x squared, but we got negative 6x squared. So hopefully, when we do the next distribution, things work out. Let's see. Well, x times this, that's going to give us an x squared term. We want to end up with negative 2x squared, so it looks like I want positive 4 here. So I get 4x times x is positive 4x squared. Yeah, that looks good. When we put the 4x there, though, we also have to do negative 3 times the 4x. So that will give us negative 12x. But we wanted negative 5x. So when we do the next distribution, x times c, that's going to have to give us 7x. So this will be a 7 here. So x times 7 is 7x, giving us the 5x. And then we do the last distribution here, negative 3 times 7, which is negative 21, which exactly matches, so everything lines up. So in order to make this work, it looks like B was 4 and C is 7. For the next problem, it looks completely different. It says determine the quotient when this is divided by this. Now, the trick with these problems to me is we want to turn this our division problem into a multiplication problem, because multiplication is an easier operation to work with. So this divided by this will give us a quotient. Quotient is a general term for the answer to a division problem. Now to turn this into a multiplication problem, what we can do is we can say, well, to get rid of the division, multiply by 2x plus 3 on both sides of the equation. This cancels out, giving us 6x cubed minus 3x squared minus 10x plus 12 equals 2x plus 3. Oops, that's not a 3. 2x plus 3 times whatever our quotient is. So, because we're trying to find the quotient, we don't have any of the terms. So we need to figure out what each term is to make this work. So we do 2x times the first term. That has to give us 6x cubed. That is 3x squared. 2x times 3x squared is 6x cubed. And what you should notice as we do this is the exact same problem that we just solved above. We turned this division problem into the distribution problem we had above. So 2x times 3x squared was 6x cubed, which is great because that's what we wanted. But when we put the 3x squared here, it also gives us 3 times 3x squared, which is 9x squared. However, that's not so good because we want to get negative 3x squared. So there must be a next term. So when we combine these, we get negative 3x squared. So it looks like we want to get negative 12, so let's see, negative 6x. 2x times negative 6x is negative 12x squared. 9 minus 12 is negative 3. That looks good. 3 times negative 6x is negative 18x. But we didn't want negative 18x, we wanted negative 10x. So it looks like we need a next term to create negative 10x. So we want to generate 8x, it looks like. So 2x times 4 would give us 8x. Negative 18 plus 8 is negative 10. And then 3 times 4 is 12, which is great news because that was our last one and we wanted 12. Life is good. The one thing that might be difficult here is where is the answer to our problem? The answer to our problem was we were trying to find the quotient. This pink group in parentheses, this is our quotient. So the quotient for the division problem was 3x squared minus 6x plus 4. Great. Problem 3 is very similar, so I'm going to skip going over this one. Problem 4 is very similar, so I'm going to skip going over this one. But I am going to go over the next two, problems 5 and 6, even though they look very similar, because problems 5 and 6 will highlight some things that could go wrong as we solve a problem like this. So here we've got 2x cubed minus 38x minus 24. Wow, big numbers. All over x plus 4. And we want to determine what the pink quotient is as we divide these. Of course, division is probably the most challenging operation out of all 4 fundamental operations. So let's multiply by x plus 4 on both sides to turn our division problem into a multiplication problem. So we'll end up with our x plus 4 times our pink quotient. Now quotient, that's the thing we're trying to find. So rather than find it through division, we can find it through multiplication. X times the first number has to give us 2x cubed. That would make this 2x squared. X times 2x squared is 2x cubed. So that is perfect. Now, when we put the 2x squared there, we also do 4 times 2x squared, giving us 8x squared. Now, this is a problem. If you look back at the original problem, or the original polynomial here, there is no x squared term. So somehow we have an x squared term from our distribution, but we want to end up with no x squared term. So we have to think a little bit here. We have to decide what number do we put here in the parentheses so that the next group we generate completely cancels out the 8x squared. Well, I'd like to get a negative version of this. So maybe if we had negative 8x here, let's see, x times negative 8x, that's negative 8x squared. Positive and negative 8x squared will cancel out here. But when we put the negative 8x there, we also get negative 32x. But we wanted negative 38x. So it looks like we're going to need a next term. So when we combine them, we get negative 38x. So x times negative 6 gives us negative 6x. Combining these two gives us negative 38x, which is perfect. And then 4 times negative 6 is negative 24, which is great because that's exactly what we wanted to end with. So where is our answer to this problem? The answer to our problem is the pink quotient right here. So what was tricky about this problem was usually we have x cubed, x squared, x, and a constant. This time we had no x squared. But the only thing we had to do was figure out a future term to cancel them out. In the next problem, we're going to see something else that can go wrong. So this problem looks totally normal. Maybe it's a really high power 4, but we've got 4, 3, 2, 1, 0. We've got all the regular terms that we're used to having. I hope you saw 4, 3, 2, 1, 0. I was talking about the exponents, not just saying random numbers. So let's set this one up and see what happens. We want to find the quotient when we divide this monster polynomial by x minus 2. Okay, whenever you do a division problem, the answer will be a quotient. Now, we can multiply by x minus 2 on both sides to cancel out the division. That will give us 2x to the 4th minus 9x cubed plus 10x squared plus 10x minus 20 equals the red x minus 2 times our pink quotient. So the quotient, that's the thing we're trying to find. So let's find it. Okay, x times 2x cubed gives us 2x to the 4th. So far, so good. Negative 2 times 2x cubed gives us negative 4x cubed. But we wanted negative 9x cubed. So we need to have a next term that will give us negative 9x cubed in total. It looks like x times negative 5x squared. Nope, sorry, positive 5x. Nope. I had to write negative 5x squared will give us negative 5x cubed, which is negative 9x cubed. Negative 2 times negative 5x squared is going to be positive 10x squared, which, oh gosh, this is the weird part of the problem. So usually we take two terms to create the term that we want. In this case, we wanted 10x squared, and we already got it. So there is no future term that we have to generate here to make 10x squared to match the original. So because there's no future term here we need to generate, we can move directly ahead to the next term in the original polynomial and generate that one instead. So 10x squared checks off 10x squared. Now we look at the next term in the polynomial since we're done with 10x squared. X times 10 would give us 10x, and then negative 2 times 10 would give us negative 20. And that's great because everything matches. So this one was a little bit different. Let's see how different. Let's pull the quotient aside. The quotient, final answer to the problem was 2x cubed minus 5x squared plus 10. So what was different about this one was, usually it takes two terms to generate the term that we're looking for, 9x cubed, negative 9x cubed. In this case, for this term, it immediately matched. We needed no subsequent term. And what that does is it actually means that if you look at your quotient, we're missing one of the terms. We've got powers of 3, 2, but we're missing just x here. And that's okay. That comes from this fact as we solve the problem. I hope this was helpful and illustrated a couple of the unusual cases you might see with polynomial division.